Welcome to PO2 Chapter 3.4. In this lesson, we'll continue with our series of lessons on arithmetic and geometric sequence series. Now, before we begin with geometric series, okay, remember this chapter, you'll need to remember five formulae. Okay, we're gonna learn the fourth one today in this video. So, can I invite you? Okay, do you remember the previous three formulae for the arithmetic sequence, arithmetic series, and geometric sequence? I'll give you time to write down just a bit of revision. If you don't remember it, you can go back to previous videos and have a look. So these are the three formulae. Okay, so you should remember them off by heart. Okay, so don't get it mixed up. Even left hand side, one is UN, one is self SN. S because series means sum. Okay, so you're gonna add up all together. So that's why it's SN. U means is the term, position of term. So UN means if U1 means the first term, UN means the nth term. Right, back to geometric series formula. You're going to learn about, so this is the formula, A times 1 minus R to the power of N over 1 minus R. Or you can actually swap the R and N over. So it doesn't matter which one you remember, just remember one of them is fine. I can't remember, I think this formula is given in formula booklet, but I can't remember which way around the formula gave it to you. Formula booklet gave it to you. But anyway, just remember one of them. I might just use both of them, either one of them, because, my brain sometimes just do 1 minus R, and then sometimes my brain does R minus N, R to the power of N minus 1. I can't help it, just a weird brain. So yeah, the reason why you can swap them around is because imagine you multiply top and bottom by -1, then you just simply change the sign inside bracket as well, up and down. So that's why it works. Here, geometric sequence. Okay, so we have to prove this. Now we again, same as last lesson, we're gonna leave this till the end. I'll come back to this one. So let's have a look on how we can use them first. Find a sum. Okay, so let's write again. This is a geometric series. Remember, geometric series, geometric means term by term, there's a common ratio. Okay, so let me write that. So Sn equals A times 1 minus R to the power of N over 1 minus R. So question A, want to find the first 10 terms. So A, the first term is 2. The ratio, we're multiplying by 3 each time, and N is 10. So we can do S10 equals to A, 2 times 1 minus 3 to the power of 10 over 1 minus 3. Okay, just put it in the calculator. You should get 59,048 if my notes is correct, or if my mental math is correct. This, who can't do this mentally? If you can't, that shouldn't be a problem because I can't as well. Right, this one, let's do. Okay, question. So A, the first term is 10,024. The ratio. Now you can see the sign alternates. Therefore, the ratio is going to be a negative. Okay, so negative we multiply by half each time, so negative a half. The n. Okay, so we don't know how many terms are there, but you can sort of work it out yourself. Now the last term is 1. So you can think of that, you can see multiply by half each time. So if you count it yourself, so the next term will be 64, and then 32, and then 16, and then 8, 4, 2, 1. If you count them, there should be 11 terms. Okay, so you just count it manually. You can write some notes next to it. Why is it n? Why is it n11? Okay, so S11 equals to 1024. A times 1 minus R to the power of N. Now make sure you put a bracket around it when you have a negative R over 1 minus R. Okay, and then you put in the calculator, you should get 683. Okay, right. Simple as. Okay, your turn. Okay, have a go at these two practice questions. Okay, pause the video, have a go at the question. When you're ready for the answer, you can press play. And here are the answers. I don't think I have to explain too much. Just figuring out the values of A, R, and N. First 10 terms, so therefore S10. Here, I deliberately tried the other way around to show you R to the power of N minus 1. I can do it both ways. Put in a calculator, you get the same answer. Okay, right, easy peasy. Right, example, next one. Find the least value of N such that the sum 1 plus 2 plus 4 plus 8 N terms would exceed 2 million. So exceed 2 million. So first of all, we need to check this if this is arithmetic or geometric sequence or series rather. we can see we're multiplying by 2 each time. So this is definitely a geometric series. Series because we're adding all the terms together. So I recall straight away in an exam, I'll recall the formula. Okay. Right. So I want this greater than 2 million. So what I'm going to do is, okay, so I'm going to find the nth term. So A, which is 1. Okay. So in here, A equals 1, R equals 2. Okay. Simple. So 1 times 1 minus 2 to the power of n over 1 minus R2 will exceed 2 million. 3, 4, 5, 6. Okay. So I simplify it. Denominator 1 minus 2 is minus 1. Multiply across. Okay, now when you multiply -1 across, you change the sign. Okay, so let me write it. Okay, step by step. So in here, the numerator, here, I'm just going to rewrite this, have a middle step. So when you multiply -1, you change the sign. Okay, just to make sure you're aware of that. Okay, sign changes when multiplying or dividing negative numbers. I use hashtag for the short form for numbers. Mathematicians are lazy. That's why we have so many symbols. Right, next, so next, I'm going to multiply not multiply, bring the minus 2 into right hand side, so it can become a plus, and the 2 million, I'm going to move to left, becomes a negative. So 1 take away 2 million, 2, 3, 4, 5, 6, less than 2 to the power of n. Okay, so next one, this one, if I put in a calculator, you will get -1,999,999 less than 2 to the power of n. Now, you might be thinking, how do you solve this? Right, so n is the power. So what do? We can take log on both sides or we can take ln on both sides. Okay. Right, I was wondering what mistake have I made because when I try ln, I realized I can't add a negative number. Silly me, I forgot to put a -1 in there. So when it becomes a minus, this become a plus. If that becomes a plus, that becomes 2,000,001. My mistake, I make mistake as well. It's completely normal to make mistake, and the thing is, you've owned up to it. Just kidding, I'm a math teacher, I never make mistake. Not in front of people. Right, so now we've got 2,000,001. So 2 to the power of n, okay, we'll take ln on both sides, or take log, whichever you prefer. So I'm going to take ln to, once you take ln, the reason we take ln is because we can use a power law to take out the value of n. So n ln 2 less than ln 2. And divide ln 2 across. So ln 2, 1, 2, 3, 4, 5, 6 over ln 2. So that one. Right. So put in a calculator, ln, so a fraction, ln 2,000,001, 1, 2, 3, 4, 5, 5 zeros and 1 over ln 2, I get 20.93. So n has to be greater than 20.93. Therefore, n has to be 21. Okay? Right, I made a little silly mistake in here with the negative. But anyway, right. So, your turn. Okay? Exam practice. Okay? Have a go at the question. When you're ready for the answer, you can press play. Right, so let's carry on. Here's the answer. Okay, question A, common ratio is 0.75. Okay, I don't think there's any issue. If you're struggling to use any formula, whatever, I just say count the terms. The easiest way is to write out the terms and then try to find out that way. Geometric series means they multiply by common ratio. So R equals 0.75. Part B, just work backwards. 192 divided by 0.75, you get 256. Now, part C, however, there is a small detail that a lot of people probably will get a big mistake on. I'll go through. First of all, we are told Sn greater than 1,000. Nothing new. We set up the formula. Nothing new in here. Nothing new. I just multiply 0.25 divided by 256. So I get 125 over 128. Nothing new. So then my next step, I reverse swap around the terms. So my n is on one side and numbers on the other. So I see n in the power, so we log on the both side. But here comes the issue. When I divide by log 0.75, okay, some of you might know where when you log a number that's less than 1, you get negative answer. So you get negative answer. So you should divide. When you divide a negative, you change the sign. Okay, change the sign. Therefore, n is now greater than 13.047. Therefore, n is 14. Now, you might be thinking, is there a way? Oh, so I don't know about log negative. That's a very small thing that sometimes I overlook. Is there a way we can avoid this silly mistake any chance? Yes, you can. What you can do is, instead of making greater than 1,000, okay, what you can do is you can let it to be equal 0, alternatively, or, okay. So why don't we let Sn equals 1,000? Then that way you don't have to deal with any inequality, right? So because in here, what will happen is you'll get essentially you'll get the next step. It's the same step in here, being log 3 over 128 equals n log 0.75. When you divide it over, you get n equals to 13.047. So you just have to know 13.047 give you 1,000. Therefore, if you want to exceed 1,000, n has to be 14. That is equally fine as well. Okay, so if you don't want to deal with inequality, you can use the equal sign. Okay, that might work. Sometimes works better. Okay. So last but not least, you also need to learn how to prove the geometric series formula. You have learned how to prove the arithmetic series formula by reversing the order, writing it, add it together, divide by 2. Hope you remember that. If you don't, you can go back to the 3.2 video. But in this one, you have to learn how to prove the geometric series. So like the previous time, we have to start by writing out the series itself by stating the definition, the terms by term what it is. So we start by, okay, the first term will be A. Okay. Now because it's a geometric series, common difference R, that means the next term will be AR. Okay, and the next term AR squared. Next one, AR cubed, for instance, up to all the way to AR to the power of n minus 1. Now, not to power of n, because if you look at this one, if you look at the power of r in relation to the number of term, the position of a term, you can see the first term is r to the power of 0. Second term, r to the power of 1. Third term, r squared. And that's why in the nth term, the power is n minus 1, not n. Okay, just to make you aware of that. So next thing we're going to do is we are going to times this by r. So it's different to arithmetic. What I'm going to do is multiply everything by r. So r times a plus ar plus ar squared plus dot 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 plus ar to the power of n minus 1. Next, what can we do? Now, if we expand the bracket, then we get r, r Sn equals AR plus AR squared plus AR cubed plus dot dot dot. If we multiply by R, then the power of R increased by 1. So AR to the power of N. Next, we're going to do the equation in here, Sn minus the equation of RSN. So we're going to do this. So we're going to do Sn minus RSN. So just color code it for you. That's the what we. Okay, so how does it work? Sn is A plus AR plus AR squared plus dot 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 all the way to AR to the power of n minus 1. That's Sn. Okay. Subtract bracket RSN. AR AR squared plus AR cubed plus dot 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 plus AR to the power of n. So this is the RSN. That's Sn. Okay. Now how does that? When we subtract it, what you realize is the AR and the AR cancel out. AR squared and AR squared cancel out. AR to the power of n minus 1 will cancel out with AR to the power of n minus 1 inside this bracket. So what we're just left with A plus AR to the power of n. Oh, sorry, minus rather. Minus because it's a minus. Right? So that's Sn minus RSN. Then what? Factorize the Sn. And on the right hand side, we'll factorize the A. And then let's divide it over. Proven. Okay, proven. Okay, so quickly write Sn out. Okay, A second term, AR to the power of 1, AR to the power of 2, AR to the power of 3, up to AR to the power of n minus 1. Then multiply a whole series by R, expand it, and do Sn minus Rsn, factorize on both sides, divide it over, make Sn a subject. Okay, and that will be the end of the chapter 3.4.